Bazooka antenna is a coaxial dipole antenna with the main part made of coaxial cable. It was originally designed by the staff at Massachusetts Institute of Technology for radar use with coaxial cable for the entire radiating elements. Adaptation for ham radio uses coaxial cable only for the broadbanding portion, while ladder line is used for the rest of the antenna. Bazooka antenna is a single band antenna with a broad bandwidth within the band, unlike the dipole which has only a bandwidth up to 100 kHz. Moreover, bazooka antenna does not radiate harmonics of the operating frequency and feed line radiation is very little. Bazooka antenna modified for ham radio uses does not need a matching balun and can be directly connected with 50 ohm coax. As the antenna has no exposed metal wire, static charges do not build up and reduces noise compared to exposed wire antennas. Bazooka antenna consists of a half wavelength coaxial line with outer conductor cut at the center and the feed line connected to the cut ends of the outer conductor. Inner conductor is not cut and does not radiate. It acts as a quarter wave shorted stub and serves to increase the bandwidth by cancelling reactance at off resonant frequencies. Central conductor and shield of the antenna element coax are soldered together at both ends, shorted. Two wires of the ladder lines are soldered to this joint on both sides of the coaxial antenna elements. The other ends of the ladder lines are also shorted by soldering the wires together. K5IJB has provided calculations of lengths of the coaxial cable segments and twin lead segments for various amateur radio bands from 40 meter to 6 meter. Folded dipole antennas were a common sight on rooftops as part of Yagi-Uda television antennas in the past. Now with cable television becoming more popular, we seldom see any folded dipole antennas on rooftops in my region. Still, folded dipole antennas as part of Yagi-Uda directional beam antennas are popular among radio amateurs who operate on VHF and UHF frequencies of the radio spectrum. Viewing from a homebrewer's aspect, it is technically more difficult to make folded dipole antennas as you have to bend the aluminum tubings usually used for such antennas at right angles twice on both sides. Hence, I am yet to venture into homebrewing of a folded dipole antenna. Folded dipole can be considered as a dipole antenna on top of which a loop of conductor is added so that it will be short circuiting any direct current fed to the antenna, though antennas are typically fed with alternating currents. Folded dipole is a balanced antenna and has to be fed by a balanced feeder like a twin lead ladder line. If a coaxial cable is used to feed the folded dipole antenna, a balun or balanced to unbalanced transformer has to be used. While the usual half-wave dipole antenna has an impedance of about 70 ohms, folded dipole antenna has an impedance of around 280 ohms. So it matches well with a ladder line of 300 ohms impedance. Earlier, twin lead ribbon tapes were used to connect the folded dipole antenna to the television receiver. Folded dipole antenna has a higher bandwidth than the usual half-wave dipole antenna. There can be variants of the dipole antenna in which the additional conductor loop can have a different thickness with a change in the feed point impedance. Another implementation is adding another loop on top of the first loop so that 3 longitudinal regions are there for the folded dipole. Such multi-conductor folded dipoles can have an impedance of 600 ohms instead of the 300 ohms of the standard folded dipole. Bandwidth is higher for such folded dipoles. One reason for using folded dipoles instead of usual dipoles in Yagi-Uda antenna is to increase the impedance. When parasitic elements are there close by, the impedance of a standard half-wave dipole antenna may be reduced, sometimes making matching difficult. Another reason for considering folded dipole as part of Yagi-Uda antenna is to increase the bandwidth in order to cover a full amateur radio band. Radiation pattern of a folded dipole is similar to the standard half-wave dipole in a figure of 8 pattern in the E-plane. As the two conductors are near each other, the folded dipole is considered like a single conductor of half wavelength and has a directivity similar to half-wave dipole. The distance between the conductors is small compared to the wavelength of the operating frequency. In a folded dipole antenna, a half-wavelength conductor is folded into a longitudinal loop and fed at the center. It has a higher impedance of around 280 ohms compared to the 70 ohms impedance of a horizontal half-wave dipole antenna. Hence, while a coaxial cable is suited for a horizontal half-wave dipole antenna, a twin-lead transmission line with about 300 ohms impedance is used for a folded half-wave dipole antenna. Half-wave folded dipole is commonly used as the driven element of a Yagi multi-element antenna. Like a half-wave dipole antenna, the folded dipole is also resonant and radiates well at odd integer multiples of half wavelengths. As mentioned in case of half-wave dipole antenna, it acts as a 3/2 wavelength dipole at 3 times the fundamental frequency. Folded half-wave dipole antenna is preferred when the impedance has to be higher. Gamma impedance match for the antenna is also known simply as gamma match. In case of a Yagi-Uda type of antenna, it allows the driven element to be a single rod or tube without being cut at the feed point, giving more physical integrity to the system. As the RF voltage at the center of a half-wave antenna is 0, the outer sleeve of the coax can be connected here, which corresponds to the position on the boom as well. The central conductor of the coax is then connected beyond the center point through a capacitor to tune out the inductance of connecting arm of antenna. The name gamma match comes from the resemblance of the shape of connection region to the Greek alphabet gamma. As the gamma match forms an unbalanced system, it can be connected to the coax without a balun, as both the coax and the antenna are unbalanced in this case. Capacitor in the circuit is initially a variable capacitor, which is replaced by a corresponding fixed value capacitor after tuning. Gamma match is often used for an HF antenna and sometimes for a VHF antenna. When fed by a 50 ohms unbalanced coax feeder, length of the gamma rod is about 5% of the wavelength. Its diameter is typically half that of the driven element. Spacing between the gamma rod and the driven element is about 0.7% of the wavelength. Value of the capacitor will be about 7 picofarad for a meter of the wavelength. Most of the antennas which radio amateurs use on HF, VHF, UHF bands have linear polarization, either vertical or horizontal, and are not ideal for satellite communications. Polarization of an antenna is the direction of electric field produced by the antenna and determines the direction of transmission and reception. In circular polarization, the radio waves rotate as the signal propagates. If it rotates to the right, it is known as right-hand circular polarization, RHCP, and if it rotates to the left, as left-hand circular polarization, LHCP. Using circularly polarized antennas helps to minimize the effects of cross-polarization losses as the satellite moves through space. Even if the satellite antenna is vertically polarized, the signal changes direction as the satellite tumbles and spins in orbit. Cross-polarization means polarization of the transmitting antenna and receiving antenna are at right angles to each other, producing great signal loss near to total in ideal conditions. If your antenna is circularly polarized, the signal loss will not be total when the satellite tumbles and spins in orbit. Difference in signals received between right and left hand circular polarization will be only 3 dB, unlike that between horizontal and vertical polarizations, which could be near total loss of signal regardless of how much power is used. Often amateur radio satellite builders use circularly polarized antennas on them. A popular form of omnidirectional antenna for a base station is known as egg beater antenna because the shape resembles an actual egg beater used in the kitchen. Another type of antenna with circular polarization is a quadrifilar helix antenna.